Hello, this is Advanced Algebra 1, 5th period. I'm going to get set up and see if anyone joins me. If you hear weird noises in the background, that's just my crazy dog eating a bone. Alright, let's see. It looks like I have one person watching. I bet it's Brittany. I can't see who it is yet. Hey, I had 6 people watching my 6th and 7th period video. That was exciting. And now they're done. Okay, no one's here. I'm going to go ahead and teach it anyway. Maybe someone will go back and watch the video later. Today is April 23rd. We are starting a new section. We just finished radicals. Y'all should have taken your quiz on radicals. And we're starting with quadratic equations. Now we're doing a whole big lesson on quadratic functions. We're going to be doing a lot of stuff in quadratic functions. A quadratic equation is in this general form, ax squared plus bx plus c. That's the standard form. If it's set equal to y, then that you would call that a quadratic function. If it's set equal to 0, it's a quadratic equation. Now, something that's really important that you know is that when you graph a quadratic function and get your x and your y coordinates, you can do an xy table and fill numbers in for x to see what y equals and plot those points. You'll get something that looks like this, a parabola. It can be turned up, right side up like this, or it can be turned upside down. It's always going to be either turned up or down, and it is called a parabola. In that parabola, we are going to learn how to graph these, and we're going to have to find some key points to graph these. And 2 of the key points, or sometimes there's just one, and sometimes there's actually none, but most of the time you have 2 x-intercepts, and the x-intercept is where the parabola crosses the x-axis. So like these 2 points right here would be your x-intercepts of your parabola. It's very important to be able to find those. And those x-intercepts are the solutions to your equation, also called the roots to your equation. They're also called the zeros. They're very important, so they have lots of names. Roots, solutions, zeros to your quadratic equation. And what we're going to be doing for the next several lessons is looking at how to find those. There's different methods to solve. I don't know if you've ever heard of the quadratic formula. It's a really big concept in algebra. But the quadratic formula is used to find your solutions in your quadratic equation, which would be your x-intercepts. But we're going to learn first how to factor and solve to find the x-intercepts. So our goals today are to use the zero product property to solve, and then also to factor to solve. The zero product property just leads us up to being able to factor to solve. So that's the two things we're doing. You're going to have two lessons again on your IXL. The first lesson goes with girl number 1. The second lesson is going to go with girl number 2. There's Brittany. I knew you'd be on here. All right, I'm going to sit here for a second, Brittany, and let you get caught up. I don't know when you joined. But I'll just kind of repeat what I said, because like I said, I don't know when you joined. But we're starting a whole big lesson on quadratic equations and quadratic functions. And if you look at this, this is just the standard form. Ax squared plus bx plus c equals 0. That's the standard form for a quadratic equation. The main idea being that you have a term that has an x squared with it. And when you graph a quadratic function, you always get a parabola. And on that parabola, we're going to be learning in this whole big unit how to find points to make our parabola. Two of the key points are your x-intercepts, where your parabola goes to the x-axis. And what we're going to be doing today is going to find out how to find those by factoring. This says the x-intercepts are solutions to your quadratic equation. So when you find your solution to your quadratic equation, that tells you what your x-intercepts are. That's why it's important. So we're going to be factoring to solve, and we're going to be using the zero product property to solve. We're not going to do any graphing today. All we're doing is learning how to find these zeros, which are the x-intercepts. We're going to do that through factoring. Okay. First of all, before we can factor, we have to understand the zero product property, because that's involved in getting the solution. So if you look at this zero product property, it tells us that when you multiply two things together, A and B in this case, A times B, and you know that that answer is equal to 0, well, you know that either A has to equal 0 or B has to equal 0. Because when you multiply two factors together to get 0, one of those factors has to be 0. That's all the zero product property is saying. So you're going to have some problems that start out in this form, like the zero product properties is showing right here. You're going to have some problems that start out like this example 1. It says solve x plus 3 times x minus 1 equals 0. Well, see, this parentheses is one factor, and this parentheses is one factor. So if those two factors multiplied together equals 0, that means at least one of these has to equal 0. So to find out your answer for x, which is what we're trying to do, anytime you solve an equation, you're trying to find out what the solution for that variable is. And to find it, you just take whatever's in the parentheses, x plus 3, and you set it equal to 0. And then you just solve that equation. To solve that equation, we subtract 3 on both sides. And you get x equals 0 minus 3, which is negative 3. So negative 3 is one of your solutions. And then you do the same thing for the second parentheses. You just say x minus 1 equals 0. Now solve that equation for x. So you're going to add 1 to both sides. And you get x equals 0 plus 1, which is 1. So those are your two solutions. And I believe when you enter it in the, the little box on IXL, you'll just put the two numbers, like you will put negative 3, comma 1. You won't have to put x equals. And this IXL lesson on the zero product property is so easy. It's really easy. All right, example 2. Let me make sure that's in view. All right. Now look at this problem. We've got solve f times 3f minus 6 times 2f plus 5. This time we've got 3 factors. F is a factor also, so we've got 1, 2, 3 factors. And if those 3 factors multiplied together equal 0, that means either one or all of them have to equal 0. So you just take each factor one at a time. the one on the outside, f, you take that factor and you set it equal to 0. And there's nothing to solve here. That's just one of your answers, 0. Because there's nothing to divide by, there's nothing to add. It's just f equals 0. And then you take your next factor, 3f minus 6, and you set that equal to 0. And then you solve that two-step equation. So you're going to add 6 to both sides. You get 3f equals 6. And when you divide, you get f equals 2. Let me make sure that's in range, in your viewing range. So f equals 2 is one of your answers. And then you have 2f plus 5 equals 0. And you solve that equation. So you're going to subtract 5 on both sides. When you subtract 5, you're going to get 2f equals negative 5. And then you divide by 2. And you can't actually divide 5 by 2. So you'll need to write this in fraction form as negative 5 over 2. And I'm not sure if they'll have fraction boxes. If they don't, you'll just use the slash key for your fraction. Now, the more of these we do, you'll probably figure out by looking at what's in the parentheses and what your final answer is, kind of a shortcut way to do it, where you don't have to show all these steps. And you'll probably catch on to that with these next examples that we do. All right, so that is the zero product property. That was goal number 1. And now we're going to actually get into goal number 2, which is what this lesson is really all about, factoring. And then doing what we just did. We want to factor first and then use the zero product property. So you're going to have to remember back whenever we did factoring. I'm trying to think when our test was on factoring. It might have been one of our last tests before we did radicals, before we got out of school. All right. Now, notice our directions on here still say the same thing that the directions in example 1 and 2 said. It says solve. But before you solve, when you look at this, what you should notice is that that is a trinomial in standard form. It's not in the zero product property form. So you've got to factor it first to get your two parentheses. Uh-oh, I'll drop my pen. So, remember when you factor a trinomial, you're going to put your two parentheses down. Keep your equals 0. And remember, if there's no number in front, you're just going to put the q's in the first spot in each parentheses. You're going to split your q's apart. Q times q is q to the second. And then remember, you're looking for two numbers that multiply together to give you negative 24 to put at the end of each parentheses. And then they have to add to be positive 23. So that means that you're going to have a positive 24 times a negative 1. Positive 24 times negative 1 is negative 24. And positive 24 plus negative 1 is positive 23. So that's factoring. We've already had a test on that. And then once it's factored, you just do what we did in example 1 and 2. You do the zero product property. So you're going to say q plus 24 equals 0. And then solve that by subtracting 24 on both sides. So you'll get q equals negative 24. And then in the other parentheses, you have q minus 1 equals 0. So now solve that equation for q by adding 1 to both sides. And you get q equals 1. All right, now before I go on, let's look back and see if you can see the shortcut way to get your two answers without showing the 1 or 2 step equation that you're solving. Let me put this back up here. All right, if you will look at this, x plus 3 times x minus 1, and then look at our final answers, -3 and +1. All you do is just, when you've got your two parentheses, it's always going to be the opposite sign of the back over the front. That's what I always tell my students to remember. It's the opposite of the back over the front. So that would be -3 over 1, which is -3. The opposite of the back over the front, which would be +1 over 1, which is +1. All right, so look down here at this one. 3f minus 6. So we could skip these steps right here to go straight to our answer. It's going to be the opposite of the back over the front. So it'd be a +6 over 3. +6 over 3 is 2. For 2f plus 5 equals 0, that's going to be the opposite of back over the front. So opposite of 5 over 2, -5 over 2. Okay. And then this example 3 that we just did. Once you get your two parentheses, plus 24 minus 1, it's going to be the opposite of the back over the front. So -24 over 1, which is -24. The opposite of 1 over 1, which is +1. Okay, so if you get that, you don't have to write these equations down after you factor them. You can go straight to the answer. So look at example 4. Example 4, you have n to the second minus 6n plus 9. So we want to factor first, which is going to be n and n. And then you want to get a +9 when you multiply, but you want to get a -6 when you add. So that's going to be a -3 and a -3. All right, if you notice, you've got the same exact parentheses, so that means you only enter your answer once. This is going to be n equals the opposite of the back over the front, which is going to be +3 over 1, which is just +3. And it's going to be the same thing here. You're going to get n equals the opposite of the back over the front, which is going to be just a +3. And then on IXL, you would only enter 3 one time. Hey, Hayden. Okay, example 5. Here we're going to solve p to the second plus 40p equals 0. So now what you should notice is this looks different. There's not a trinomial. You've got two terms, and you're missing that third term at the end. So you can't factor it into your two parentheses like we did on our trinomials. This one you just pull out of GCF. All right, p squared plus 40p, what is the GCF? It's p, because both terms have a p. So you pull your p out front, and then when you pull a p out of p squared, you're left with a p. And when you pull a p out of 40p, you're left with 40. So p times p plus 40, that's just factoring using your GCF. And now you've got two factors. P, you set p equal to 0, and then you have p plus 40. So you set p plus 40 equal to 0. And so p equals 0 is an answer. P equals -40. When you solve that equation for p, you have to move your 40 over to the other side. So p equals -40. All right. Example 6. Let's see, let me see how many examples we have. We have 8 examples. The last 2 are a little bit harder than the others. So, Brittany, if you're still here, just hang on, because the last 2, I think you need to see me work live. Alright, example 6. Again, we want to solve 84x squared minus 76x. What you should notice is that there is no trinomial, but these 2 terms have a GCF, and so we want to pull our GCF out. The GCF between 84 and 76, I believe, is 4. I don't have my calculator here. There may be a larger one, but I'm going to go with, well, no, there is a larger one. Hang on. No, I think it's just 4. Let's pull a 4 out. 4x. And then we're going to divide 4x into each of these terms. So 4 goes into 84 21 times. And you've got to have another x. 4x times 21x is 84x to the second. And then minus 4 goes into 76. Is it 19? I believe it's 19. And you don't put an x with it because you've already pulled that x out front. Yes, that was right. 4 was the largest. It was the GCF because I can tell, because 21 and 19 have no other common factor. That means I pulled the largest one out. So now you're ready to get your 2 answers. So you take your 4x and set it equal to 0. And then divide both sides by 4, and you'll still get x equals 0. That's one of your answers. And then on this next one, I'm going to go ahead and take a shortcut and not write it down as 21x minus 19 equals 0 and solve it. I'm going to go ahead and get the answer. Remember, it's x equals the opposite, which is positive, of the back over the front. So it's going to be 19 over 21. Remember, on IXL, you're going to enter that as 19/21 if there is no fraction bar. All right, the last one on this page, and then we've got one more example on the next page. This one is a trinomial. 2m squared minus 23m plus 11 equals 0. So it is a trinomial. Now this is one of those trinomials. There is no GCF that we can pull out. And it has a number in front of my m squared. So remember, this is one that I taught y'all to use that slide, divide, bottoms up method. The method that Cadence liked. Cadence needs to be here. So, what we're going to do, if you remember how to use that method, we take this 2 and we slide it to the end and multiply by 11. And then write that trinomial down. You're going to have m squared minus 23m plus 2 times 11, which is 22. And then we're going to factor this. I'm going to bring my equal 0 down. And now we're going to factor this trinomial. And so we're looking for 2 numbers that multiply to get 22, that will add to get 23. So I'm going to put my m and my m. 2 factors of 22 that will add to get 23 will be 22 and 1. So that's going to be minus 1 and minus 22. And then remember, we have to do the divide part. The divide is where you take that 2 and you put it under each number in the last spot in the parentheses. So 1 over 2 and 22 over 2. And then it's bottoms up. So the 1/2 won't simplify. So we've got to move the 2 in front of the m and make it 2m minus 1. And then on this one, 22 can be divided by 2. So you just divide that and get m minus 11. So that is the factored form. And now we've got to use our zero product property and solve and tell what m equals. So m is going to equal the opposite of the back over the front, which is going to be positive 1 over 2. And then in the other one, m is going to equal the opposite, which is going to make it positive 11 over 1, which is 11. Okay, so I'm going to pause just a second, change papers to my last example, and then see if there's anything you need me to go back over. Just let me know if you need me to go back over any of that. All right, moving on to example 8. This is the last one. We have solve 18v to the second plus 99v plus 81 equals 0. So we're going to do this one the same way, but if you notice, these are really big numbers. It's like if you multiply 18 times 81, that's going to be too big to factor. That should be a hint to you that there's a GCF, and you always want to pull a GCF out if there is one. Remember, the slide divide bottoms up method will not work if you do it without pulling your GCF out. It has to have the GCF pulled out. So what number divides into 18, 99, and 81? Brittany, yes, we can do a Teams call later. It'll have to be like maybe late this afternoon, because I have another session coming up that's live at 2. And I've got to eat something before then. I haven't had lunch yet. So it'll be later this afternoon. I'll send you a message on Teams before I'm ready to do it. Okay. So on 18, 99, and 81, let's pull a 9 out front. And then divide 9 into, I'm probably going to have to move down here because I don't know if I left myself enough room. But when you pull your 9 out, you're going to be left with 2v to the second plus 11v plus 9. I just divided 9 into all three of those terms. And so now you have smaller things to work with in here. And we're ready to do the slide divide bottoms up method on our trinomial. You're just going to leave your 9 out front. And then I'm going to put my big parentheses. You can just forget about the 9 in the parentheses while you're working through this. But I'm going to go ahead and leave it. Okay, so I'm going to do the slide part. You're going to take 2, slide it to the end, and multiply by 9. And that leaves you with v squared plus 11v plus 18. All right, so now I'm going to factor this easy trinomial. When you factor that, you have 2 parentheses. And that's going to be v plus, remember the factors of 18, you're looking for the factors of 18 that add up to be 11. So that's going to be 9 times 2. So v plus 9 and v plus 2. And just bring that 9 down front. Now we've got to do the divide part. We've got to divide by the number that we slid. So the 2 is what we divide by. So we're going to divide by 2. Now I'm going to finish mine down here. Where's my hand? Oh. Sorry, I was looking at my laptop and it's delayed. I couldn't see my hand. All right, so I'm going to take this and move it down underneath this assignment. Let me just rewrite that right quick. 9 times v plus 9 over 2 times v plus 2 over 2 equals 0. So now we simplify these fractions. If it doesn't simplify, remember you move the bottom number up to the front. So that's going to be 9 parentheses 2v plus 9 and then v plus 1 because 2 over 2 equals 1 equals 0. So we've gone through all of that to get it factored. But remember, what you're looking for is the solution for v. So you've got to take this further than just factoring it. You've got to actually solve for v. So you take the factor on the outside and set it equal to 0. Now 9 equals 0. There's no letter with 9. So 0 is not one of your answers. It makes no sense. 9 equals 0. It makes no sense. So we're not going to pay any attention to that. But we have 2v plus 9 that we're going to set equal to 0. And you can do the shortcut method. I'm just doing the long version in case y'all forgot what we're doing actually. We're taking this parentheses right here, 2v plus 9, set it equal to 0. And v plus 1, set it equal to 0 and solve it. So we get 2v equals negative 9. Which means v is going to equal negative 9 divided by 2. And over here on this one, we just get v equals negative 1. And that's my two answers. Remember, you don't include 0 as an answer because there's no letter. That was not a letter on the outside. It was a number. Alright, so let me just kind of go over what we did. We started off with a zero product property. The zero product property, like example 1 and 2, it already has the factored parentheses for us. So all we do is solve each parentheses and get our two answers. There's no factoring on these. This one had a letter on the outside, a variable on the outside, so 0 was one of our answers. And then we just solved each parentheses. Those are the real easy ones that you don't have to worry about factoring. Then we went to the next set of examples that involved factoring. And we started out with easy trinomials that we factored and then got our two answers. We had one where you had to use the GCF, pull the GCF out, and get your two answers. And then these last two, 7 and 8, where you had to use the slide divide bottoms up method to factor it first. And then once you factor it, you have the zero product property, and you're getting your two answers. So I know it's a little bit hard, especially since I'm not there in person with you. So we will go back over that when I call you in our Teams call. Here is the assignment. You need to do IXL, Algebra 1, BB7, which is going to be the zero product property, the one that's so easy, it's really, really easy. And then BB8, the one that you have to factor first. Get a SMART score of 80 on both of them. And then I will try to message you and do a conference call later tonight. But now remember, you won't have to worry about doing any other new lesson until Monday. So I'll still call you tonight though. Well, not late tonight, but later this afternoon to see if you need any more help with this. All right, see you later. Take care.